So despite what the title says, this is end-to-end broadband access for service providers. I'm Larry Peterson from ONF and Aaron Byrd from AT&T. We're going to tag team. The other way of thinking about what this session is about is Seba, which is SDN Enabled Broadband Access. It's a combination of commodity hardware and some software to do passive optical networking, is now a candidate to be included in Akraino. And so this is the combination of Seba and Akraino. So I'm going to give you a quick overview of Seba, and then Aaron's going to take over and talk about how this all works in the context of Akraino. There will be plenty of time for questions, so feel free. I'll stop kind of midpoint and see if you have any, and then we'll continue on. But please do ask your questions. So again, a Seba overview, software-enabled broadband access. I'm going to have a few slides, and there's a demo across the hall. I encourage you to go see it if you haven't already. Basically, this is a site within a large carrier network out towards the edge where fiber to the home is implemented. We have a hardware configuration that is roughly 3 compute nodes. That's sized sufficient for high availability of the control plane. There's not a lot going on the compute nodes here. In theory, one could grow the number of compute nodes if you wanted to and put additional functions there, but that's not the configuration that we're working on now. Seba also has an aggregation switch that then is connected to some number of white box OLT devices. And I'm showing those in red here. We can span out to 16 of these OLT devices in the configuration that we're working on. Just a little context. This is a general architecture, but the exercise here is how do we harden this and size it in preparation for production deployment, which is part of the Akraino story. So while it could be this or that, right, we're targeting a particular sizing of the hardware. So there are a number of vendors that have OLT devices that we have worked with. So ultimately, Seba could deploy some combination of those. Each of them fan out to some number 64 ONUs. And so if you do the math, I think it's 16,000 potential subscribers connected to one of these sites. All right, so that's the hardware. One of the big picture ideas for Seba is that it could ultimately be configured with the BNG as part of the functionality or the BNG external to the site. The configuration that we're working on right now has the BNG external to the site. This is part of the way AT&T intends to work with it. Other operators might have different configuration parameters. So in principle, the BNG could be brought inside of the site as opposed to outside. But again, this particular configuration has it outside. And of course, there's a set of external services that we're going to depend on as we plop one of these down into a particular deployment. And I'll come back to that in a second. So that's the hardware. From a software perspective, there are 3 major pieces. Volta is a hardware abstraction for the OLT devices. It is a collection of microservices. There's like 8 microservices in there. So it's everything here that I'm going to show you now is container-based. So there's a set of Kubernetes containers running with the control plane for the OLTs. And again, we're hiding the various specifics of the OLT hardware. The abstraction that Volta gives you northbound is that of a switch. And so even though it's basically a switch modeling as a model of the entire PON. So every time an ONU connects out here, that's as though a port came on that virtual switch, the Volta virtual switch. And then upstream, each one of these OLTs is connected, has a port that connects you into the aggregation switch. All right, so now I have an abstract switch that I'm trying to control, and it's being controlled through ONOS, the Open Network Operating System from ONF. And there's a set of applications that run on top of that. ONS is also then highly available, deployed as a set of containers. And finally, on top of that then is something called NEM, which stands for Network Edge Mediator. It is the shim that sits between all of these disaggregated components inside of the site and whatever sits northbound of it, some operator OSS BSS. And so again, we're designing for generality. There are any different operator might have a different northbound OSS BSS. ONAP is certainly one option that is we ought to consider, but it's not the only one. In terms of external factors, there's going to be a DHCP server, and so there's a workflow that as somebody comes up at home and brings their residential gateway up, there's a packet flow that triggers certain events inside of the software, and I ultimately get a DHCP request that is responded to, and I get an IP address. There's a radius server external, so as I fire up an ONU and authentication packets start flowing, ultimately a query goes to radius to say, is this subscriber a good subscriber, yes or no, and that it activates that flow. So there's a lot of runtime workflows that go through this, and if we run out of things to talk about, I can come back and show you what some of those runtime workflows are, but it's really important to understand that the runtime workflow is part of the environment, is critical, part of the environment that this collection of hardware gets plopped down into. Yeah, I think that basically covers the software. Just to blow the purple box apart a little bit to see what's inside of it, it's basically another bunch of microservices. So everything, again, in the control plane are Kubernetes, microservices running on Kubernetes. And so there's some XOSs maintaining the authoritative state every time the operator from northbound says, I want to enable this subscriber, or I want to enable that ONU port. That state is maintained by XOS. And then there's a common bus that all of the components down inside of the system are sending events and metrics and log information to. And then those propagate up through Elk Stack and to Grafana on the metric side. Again, a set of microservices. And so if you stand back from all of these parts, then what this is really about, what we're really focused on is how do I deploy that functionality on that hardware in a site within an operator network. And so the way that we think about, so I'm focusing now on the installation process, which ultimately is also going to be the upgrade process. You can think of Seba as a black box that we are going to bring it up one step at a time. The way that we think about it is it's a highly configurable system, and we're going to assume first and foremost that at the bottom we've got some those three servers running, and it's going to be running Kubernetes, and we're going to leverage common CI/CD tools, particular Helm and Jenkins. So I'm trying to give you the broad picture here again that as we test this and we modify the software, there's a set of Jenkins jobs that run and they produce images. Those images ultimately going to be pulled down by Helm and installed into one of these sites. So that's the assumption of what's available to bring up this pod. We bring it up in sort of three stages. The first stage is what we call the platform. This would be common to any configuration that went anywhere that is under the Chord umbrella, of which Seba is one configuration. So I'll show you the next level is what really makes it Seba as opposed to some other variant, some other personality. So the platform has those components in it, which I've already shown you as mostly those are part of NEM plus ONS to manage to do the SDN control on the switches. So these are, again, that's the first wave of containers that are installed. XOS is itself a handful of containers. Logging and monitoring, again, were 4 containers. Once the platform is there, this is where we then install the personality that we want in this particular deployment. Seba is a personality or a flavor or a particular profile of the Chord platform. And so this is where we say, look, I want these particular services running, virtual OLT service in the Seba example. So this is where those get brought up. This is where all of these specific ONS apps themselves are started. And the control plane of, that should have said control plane, of the particular hardware devices here, that would be Voltha in this particular case. So that's the control plane for the access devices. Now, once that's up, we have an instance of Seba, but it's not been customized for a particular site into which Seba is being deployed. That's very operator specific. So if you went back to the earlier picture I had and you saw everything outside of the Seba box, we need to configure this to be able to deal with the particulars of the operational environment that this is dropped into. And so we call that the workflow. And so we have operator-defined workflows. So as an example, we have implemented something. If you go look at the code base, you'll find AT&T workflow. That is basically all of those runtime things that have to happen to interact with DHCP, to interact with Radius, to interact with whatever is external to this particular site that's part of the operational environment that we have to deploy into. Now, there is one last thing, and I'm going to sort of put it in the workflow. It's maybe a little bit different, but it's the other thing that we have to do to customize this for a particular operator. And that is each operator will want a particular syntax to be backward compatible with whatever OSS sits northbound of us. And so in this particular case, there as an example, something that we call the abstract OLT is one instance of a shim that implements the API that, in this particular case, AT&T was working with others to try to support as the interface to their northbound OSS. Okay, so it's a set of levels. We get a common platform for all cord-like deployments. We then specialize it with a profile of what Seba is an example. We then customize Seba to be specific to a particular operator that we're going to drop it into. And we do that by bringing up Kubernetes pods. So what's the transition to Akraino? It's very straightforward. I just have to change those words to Akraino. All right, basically it's a deployment environment. They've done all the work to get us to the point that we can now take this app and install it onto an Akraino edge. And with that, I'm going to turn it over to Aaron, who we'll talk a little bit more about Akraino. But maybe if there are questions very specific to Seba before we do that, this would be a perfectly fine time to take a couple of those. None at this point. Start making up your questions. You're going to get done really fast here. Aaron.
All right, thank you. Thank you, Larry. So I'm Aaron Byrd. I'm the project technical lead of the Akraino blueprint for Seba. Let me get into the... Sorry. You guys can see that. I'll just stick on... So what AT&T is, I'll try to kind of set the stage here. What we're trying to do is the intent, obviously, ONF has done a really good job of getting the Seba software developed in place. And what we're trying to do with this is try to find we're trying to get a process in place to where we can automate and rapidly deploy in an automated fashion the software that they've designed. So that entails specifying specific software or hardware that we would place this on, and then we would create a blueprint that would have the instructions on how to instantiate this software on that environment so we can replicate that 5,000 times or several thousand times if we need to. That's the problem that we're trying to solve. So within Akraino, we started the blueprint. We started this blueprint and started it. We brought the idea up late last year, and we've been working through this, slowly working through some of this stuff because we're trying to get a lab situation put in place to where we can validate this blueprint. So there's things happening in the Linux Foundation to get an environment so that we can test, validate at least 2, if not 3 lab locations, different locations with different hardware. The interesting thing about this blueprint is the expectation is that it will be deployed on not only x86 hardware, but also ARM hardware, so that providers have the ability to be able to deploy on two different types of architectures from a compute standpoint. So most people ask, what does it entail? What does Akraino entail? And this is a good representation. If the green areas kind of highlight and provide the areas at which the code will be developed within our Akraino blueprint, our team will develop the code, so that this blueprint will function. We will have the Dawn is a added code that will be added for airship. We'll be providing that code to airship so that we can help deploy that. One thing I do want to note, there are items within this blueprint, especially the items that are showing the Seba components. Some operators may opt to use different pieces, different controller. So there's certain things that they may want to try to do. And so we've seen that. We've seen suggestions of doing that. But this is what our blueprint's going to entail. And we see different flavors that may come into play as far as how other operators are going to deploy. So I'm going to pause right here, see if there's any questions on this, or if there's anything that anybody has any concern or need an understanding on. Okay? And then, Larry, I thought I'd just kind of go back through an overview just to make sure that we're, the blueprints to enable is to utilize the Foundry, the Linux, Open Network Foundation software. We're trying to keep open source, provide that in a Kubernetes cluster, and have a way of rapidly deploying it. Automation of installation. This is kind of a layout of the numbers of what we're talking about. What's the site is supposed to support, and again, back down into the architecture of each site. And that's really all I have. It's pretty straightforward. We are working on this. Our first, I can kind of tell our first release of the blueprint will be mid this year. We're trying to hit the end of second quarter. Dates are a little fuzzy because that's being worked in the community. It is an open community that we're working with. So I normally have calls on Mondays, depending on what time zone you're in. I think it's 8 a.m. for you, right? In the West Coast, it's 8 a.m. But I do an hour call every week, and we go through pieces of this, and we're working. The next phase is working through some user stories, finalizing those, getting there's a lot of work that's already done on some of the coding, and it's just a matter of putting all our ducks in a row and getting that pushed up into our repositories and having those function.
Yeah, it's a fairly straightforward process. I slightly oversimplified it by saying we make the assumption that you've got some hardware running Kubernetes and there's a tool set to help install the containers. But to a first approximation, that matches exactly what Akraino was looking for. So yes, we have to pick it up out of the test environment that we work in and make sure it is reproducible in the test environment that Akraino works in, but they look enough alike that that's a pretty straightforward process. Now, the other factor is different operators will want to tweak this and that because Akraino gives them some knobs. But once we have the first variant of this, then you're ready to start doing the tweaks. The other thing, hopefully I can say this, I can say what I want because I don't work for AT&T, but if you go to the AT&T booth and look on the floor, you'll see a little hardware enclosure, which is potentially the actual physical infrastructure that we will be deploying in. Seba doesn't need much compute hardware, so.
Yeah, and you know, we're open to testing on various hardware platforms and, you know, x86 and ARM platforms. So we want, that's the idea, is to make sure this is open, that other providers have the ability to utilize this and not be constrained. So we can work through that. That's the whole idea of the community, is to make this a working, usable blueprint. All right.
Go ahead, yeah.
Go ahead.
You just talking about wanting to work on both x86 and ARM platforms.
Yes.
Can you talk about what that involves? Is there something you need to do in terms of preparing for that? Tested already? What are the challenges?
It's actually tested. There's a presentation in the ARM booth today. There's actually a drag and drop presentation where they've already automated it. So they're testing on x86 or on ARM architecture today. The testing on x86, we personally have this deployed in production in AT&T at several locations, several central offices. So our desire to automate this is at a very high level. So we've done some automation. We're trying to push forward and get the rest of the, there's a couple small things that we need to go through the automation and provide that. So that's the intent. But you can, there's a in the ARM booth today, you can actually see a very nice presentation where they've put the deployment into about, I believe, 3 minutes. I think they've cut it down to about 3 minutes of deployment. So really nice how they've been able to deploy that. I can tell you there's some slight things that they had to do on an ARM basis. In fact, if you go to the Akraino webpage and you look under Seba, they actually have the ARM installation process and what they've actually had to do. So there's some slight code stuff, and I've requested that those changes get adjusted. Not only do they reflect in the Akraino community, but anything associated with Seba get pushed up into the ONF, so that, you know, users of ARM or x86 have the ability to look at both those. That's the desire, what we're trying to push towards.
Yeah, having it Akraino as the automation toolkit is great, but we would like to encourage everyone to, if you're touching Seba in some way, get it back into the Seba source, because that, I don't know that there'll be any other deployment platform, but we really do encourage that.
Yeah, the ARM folks have done a good job. They spent a considerable amount of time going through and getting, they just had a punch list through it and got it working. So the details of that, again, you can read on that Akraino site. They have a punch list of what they had to go through and fix. So there were some slight things that they did, but the work is done, and that will be open sourced to the community.
So I have a question for you.
Okay.
All that stuff on this picture on the right, I mean, we fake it out and, you know, have it from a testing point of view. We aren't testing against a production version of that. What's the Akraino variant of that, this stuff?
The Akraino variant of that, you know, those are systems that are pre-existing. So this wouldn't be what's instantiated in the deployment, or at least the Seba blueprint does not instantiate these services.
Right.
It's not to say that there's not a blueprint associated with some of this stuff.
But from a testing point of view, what's this Akraino story about providing at least stubs for those, or do you?
So in the initial installs that we've been doing, authentication already happens. You know, you create your accounts, the pre-setup, and you guys have a pre-setup of what you do on the server. So to make production, there's some very slight things that you make as far as adjustments, putting the right accounts, and that's kind of notated in your if you have accounts associated. So really these are things that an operator typically would handle. During your installation process, these things are kind of outlined in external OSSs. That stuff, we have standard APIs that are communicating out to that, so there's really no configuration of some of that stuff because it's being pushed through the Kafka bus. So, any other questions?
Sure.
I'm just interested how you deploy this, because presumably you're putting this in a site where you have a legacy system, it's running, serving users. Are you just ripping all of that out and replacing it, or is it coexisting? How does that?
These are actually, what we're doing with this is the current installs that we have are new customers. The place that we've had this, we've added this and added new customers to this. Would this replace? There would be obviously the equipment that this replaces. It could work side by side with. We're seeing some. I would say some definite space advantages for going with a Seba pod like this, as opposed to some of the larger OLT racks, the things that are, the chassis. OLT chassis in some cases are a pretty large chassis compared to this, like a 3-node compute with a switch configuration. So, excuse me, I can see where as you grow and as you go within in a deployment, there'll be sites where this can actually, customers can be moved over to this to offset your legacy or to end of life your legacy.
Drain, grow and drain or drain and
We
grow.
don't have, right now we don't have a current plan to replace equipment with this at this time. This is all for new growth. That's what our intent is, at least for right now.
Yep.
Continuing with last questions, considering the deployment, how big scale of this one side of your stable deployment vision, how many computer nodes, how much
How many?
So that is a site. It'll be 3 nodes, 3 compute.
considering adding stuff like GPUs or AI, what kind of bandwidth you foresee?
Currently, there's no plans for additional GPU. This right now, what we're seeing, if there were microservices or something that would need to be that would like to utilize this compute platform, we have space. We would have space to add some of that stuff. So that would be something that we'd have to, analyze what's being added, and if the need is to enhance or augment the compute power at that location, either we add another compute node, which could happen, but typically, you can augment some of the existing servers for compute. We don't see that happening just yet. What we do see happening is as this software matures and as we grow and as we move along the process, we're continuously developing and enhancing and doing things, right? So even in ONF, they're making decisions to adjust or change to make things more feasible, lower barrier entry, meaning utilizing an operating system that maybe uses a lot less resources coming in. So that's some of those things that are being worked in both sides as we go in through this. And I see that right now each of these the expectation is 16,000 subscribers that this would support, and then as you would grow into this, if you need if you've got more customers than that, obviously you put another pod in the same area. We would see multiple pods I'll call it a site, not a pod, because Akraino has their idea of what a pod is, and that's a lot different than what we're calling here. So and that's of recent changes. This is called a Seba site, And we may have multiple sites at a location that could have, you know, multiple computes to support more customers.
This is a really, so what we have here is a kind of firewall. And on one side of that firewall, we can experiment with adding VNFs and microservices and scaling up and down, and we can do all kinds of stuff over here. And then when it goes across the firewall, it gets stamped. This is now production ready to deploy at this configuration, because if you change one knob, then you're not sure it's going to work, right? That's what this is about.
Yeah, I see things changing as we get further down into, you know, some augmented reality, AI, virtual reality applications that may require compute. This is an area where we could, you know, utilize some of this compute resources. So that's something that definitely is always a consideration.
So in the diagram, the BNG is depicted to the outside.
That's correct.
Of Seba. And to the previous questions around compute resources, future possible use cases, and so forth. The BNG is offering probably subscriber traffic management.
That's correct.
Were that to become inside the four walls of Seba, would it be more envisioned that instead of being perhaps compute bound, which is not as cost optimal potentially from a data plane, play, would that be sort of the next thing for Seba to take?
Actually, it is, yeah.
Or in the pipeline subscriber?
Yeah. So you've put your finger on the. So there's sort of two paths forward for Seba, sort of from a development point of view. One is BNG functionality in the switching fabric, so that path continues, but includes the BNG functionality. The other is forking off from that, so that if I do need to hit a container, I can do that. We had that capability in Arkaino, which was a predecessor configuration of Seba. We didn't need it in this particular variant of Seba, so we kind of let it by the wayside. We need to bring that back in and the other at the same time. So those, from a roadmap point of view, where could Seba, the ONF community project, go? Those are two top priority things. Okay.
No more questions.
Thank you.
Easy crowd. Thank you, guys.